Picture Australia. Go on, actually picture it. You're probably seeing red dirt going on forever, blazing sun, maybe a kangaroo hopping through some dry grass, heat coming up off the road in waves. That's the whole vibe of the place. Driest inhabited continent on Earth. Somewhere the sun feels less like a nice thing and more like an opponent you're fighting every single day. Now throw all of that out, because for tens of millions of years, none of it was true. There was a stretch of time when Australia didn't even have a scorching sun for months on end. Not because of clouds, because the sun literally didn't come up. Picture this same country sitting in near total darkness for a third of the year, physically stuck to Antarctica, further south than New Zealand is right now, further south than any part of Australia touches today. And walking around in that darkness were dinosaurs with eyes the size of tennis balls, giant amphibians the size of cars, and a whole cast of weird creatures that would make you assume someone's messing with you if they told you Australia used to be a polar country. Nobody's messing with you though. This actually happened, and the story of how it happened, what lived through it, and how the whole thing violently fell apart is genuinely one of the strangest chapters in this continent's history. Let's start with the breakup that kicked all of this off, because Australia wasn't always its own island continent just floating out there by itself the way it is now. About 200 million years ago, basically all the land on Earth was jammed together into one giant supercontinent called Pangaea. Over time, that thing started ripping itself apart, first into two halves, a northern chunk and a southern chunk, called Gondwana. Gondwana was basically South America, Africa, India, Madagascar, Antarctica, and Australia, all mashed together into one landmass. And bit by bit, that southern half also started breaking up. Africa peeled off from South America. India broke away and went on its own long trip north, a trip that eventually ended with it smashing into Asia so hard it pushed up the Himalayas. Madagascar drifted off on its own too. But here's the part almost nobody hears about. While all that was going on, one corner of Gondwana just would not let go of each other. Antarctica, Australia, and South America stayed locked together, sometimes called East Gondwana, and they held on for a shockingly long time, well into the age of dinosaurs. In some spots, basically right up until the very end of it, which means for a huge chunk of the Cretaceous period, if you wanted to walk from what's now Argentina to what's now Melbourne, you actually could have, on foot. You'd just have to walk straight through the middle of Antarctica to get there. And this isn't just some fun geography fact. It matters because Antarctica back then looked absolutely nothing like it does now, and Australia's part in that story is bigger and way weirder than most people realize. Here's the setup. By around 100 million years ago, Australia had drifted all the way down until it was sitting almost right on top of the South Pole, somewhere between 75 and 80 degrees south. To put that in perspective, that's basically where the emptiest, iciest bits of modern Antarctica are today. If Australia was sitting there right now, there'd be nothing but ice shelves and penguins. But this wasn't right now. This was the Cretaceous, and the whole planet was running on a totally different climate setup, one with no permanent ice at either pole, and average temperatures way higher than today. So instead of a frozen wasteland, this deep south version of Australia was covered in cool, green forest. Conifers, ferns, ginkgo trees, small flowering plants just starting to show up, rivers cutting through all of it. Genuinely green, genuinely alive, and genuinely one of the weirdest places dinosaurs ever called home, because being that far south didn't get rid of the darkness problem, it just got rid of the ice. For months at a time, the sun would barely peek over the horizon, or wouldn't show up at all. So anything living down there had to figure out how to survive real, extended, bone-deep winter darkness, without the option of just walking somewhere warmer, because there wasn't anywhere warmer close enough to walk to. We actually know all of this in crazy detail because of one single place. A stretch of coastline in the state of Victoria, way down in the southeast of the country, right where the Otway Ranges meet the ocean. Today it's called Dinosaur Cove, and the only reason there are fossils sitting there at all is because of this exact breakup we're talking about. As Australia and Antarctica slowly started tearing apart, the land in between didn't just cleanly split, it sagged downward first, forming a massive rift valley, hundreds of kilometers long, and that valley filled up with rivers and forest. Sediment washed in year after year, burying whatever died there, and eventually all that sediment turned into solid rock. Millions of years later, the ground got pushed back up to the surface as the cliffs you see today at the Otway and Strzelecki Ranges, and back in the 1980s and 90s, a couple of paleontologists named Tom Rich and Patricia Rich basically blasted their way into those cliffs with dynamite and mining gear to get at what was hiding inside. What they found completely changed what people thought they knew about dinosaurs and cold weather. The single most famous thing to come out of that rock was a small plant-eating dinosaur called Leolinosaura, named after the daughter of the two researchers who found it. Nothing huge, about 1.5 meters long, walked on two legs, had a tail that was longer compared to its body than almost any other plant-eater we know of. But the detail that really made scientists sit up wasn't the tail, it was the skull. One young specimen was in such good shape that researchers could actually make out the shape of its brain cavity, and what they saw was a set of eye sockets and optic lobes that were way bigger than you'd expect for an animal that size. Big eyes, built to soak up as much light as possible in a place where there often just wasn't much light around. This wasn't some ordinary dinosaur that happened to end up somewhere cold. This looked like an animal that was physically built for months of darkness. Which brings up the obvious question. If you can't count on sunlight for a third of the year, how do you even survive that? For a while, the go-to answer was hibernation. Alongside Leolinosaura, researchers also found a different dinosaur in the same rock, a small early relative of the ostrich-mimic dinosaurs called Timmamus. Some of the early analysis on this one suggested it might have basically shut its body down for the darkest months, sleeping through the worst of the polar winter, kind of like a bear does today, except doing it as a dinosaur, something like 90 million years before bears even existed. Great story. Also turned out to be, at best, only half right. In 2011, a more detailed study went back and actually cut into the fossilized leg bones of these polar dinosaurs and looked at the growth rings inside them, basically the same way you'd count rings in a tree stump. Animals that hibernate tend to leave a very specific mark in their bones, a stress line that shows their body basically paused growing for a while. The research team checked for that mark across both the plant eaters and the small meat eaters from this site, and for the most part, it just wasn't there. The growth patterns instead looked like animals that kept growing steadily all year round, cold months included, the same way a bird just keeps functioning through winter by keeping its body temperature high and steady instead of shutting down. So the original headline was basically wrong. These weren't dinosaurs sleeping their way through winter underground. They were almost certainly small, active, warm-blooded animals that just kept moving, kept eating, kept living through total darkness, using those huge eyes to make the most of whatever faint light was around, and a body that basically never switched off. And if you think about that for a second, that's actually a way creepier image than a sleepy dinosaur curled up in a burrow. This is an animal wide awake, alert, hunting for food in pitch black, freezing cold, for months straight, like it's just a normal Tuesday for it. Leolinosaura and Timmamus weren't the only ones down there either. That same rock also gave us Atlascopcosaurus, a slightly bigger and quicker plant eater, along with Quantosaurus, a small sturdy herbivore named, kind of hilariously, after the airline that helped fund the dig. None of these animals were big. And honestly, one of the strangest things about this whole world is that almost nothing there was big, including the predators, and that opens up a genuinely weird gap in the fossil record. Even after decades of digging, researchers have found almost no evidence of any big meat-eating dinosaur living in this forest. A few scraps here, some footprints there, including a set of tracks found further along the coast at a spot called Flat Rocks, footprints roughly the size of a dinner plate, suggesting some mid-sized hunter was wandering around at some point. But nothing pointing to one big obvious top predator, the kind you'd expect almost anywhere else dinosaurs lived. So, if it wasn't a dinosaur running the show, what was? Honestly, the answer is one of the strangest animals in Australia's entire ancient history, and it isn't even a dinosaur. It's an amphibian, a 4 to 5 meter long amphibian, roughly the size of a big modern crocodile, weighing around half a ton, with a wide flat head absolutely packed with teeth. It's called Koolasuchus, and the only reason it existed at all comes down to exactly how far south this place was. Everywhere else on the planet at this point, giant amphibians like this had already gone extinct. They belonged to an old group called temnospondyls, animals that had been around since way before dinosaurs even showed up. But by the Cretaceous, real crocodiles had spread pretty much everywhere and just outcompeted them into nothing. Everywhere, that is, except here. Because real crocodiles are cold-blooded, they need outside heat to actually function, and they simply could not handle the kind of long, brutally cold, sunless winters this part of Australia was dealing with. So while crocodiles were busy taking over every river on Earth, this one corner of the world, tucked right up against the South Pole, stayed just miserable enough to keep them out completely. And in that one gap, that one weird loophole, Koolasuchus and its relatives just kept quietly surviving, completely undisturbed, for around 50 million years longer than literally every other relative of theirs anywhere on the planet. Just sit with that for a second. This thing was basically a living fossil, an evolutionary holdout hanging on in a hiding spot that only existed because the place was too miserable for the animals that would have normally wiped it out anywhere else. It sat in ambush at the bottom of rivers with its eyes on top of its head, exact same setup modern crocs use, just watching the shallows for anything coming down for a drink. And on a continent where the biggest known land predator is basically some broken theropod bones and a few footprints, this half-ton amphibian, built to grab, drag, and drown its prey, was very likely the top predator of the entire place. Small polar dinosaurs wandering down to a riverbank for a drink, in near total darkness, with this thing waiting just under the surface. Eventually, around 105 million years ago, the climate here warmed up just enough. Real crocodiles finally moved in, and did what they'd done everywhere else. Koolasuchus's numbers collapsed, and the last giant amphibian on Earth quietly went extinct. In 2022, more than 20 years after scientists first described it, it actually got voted in as the official state fossil of Victoria. Kind of a fitting honor for the thing that ran this valley long before anything most of us would recognize as a normal top predator today. Now here's where it gets even stranger, because this cut-off rift valley wasn't actually sealed off from the rest of the world. It was more like a hallway, and hallways go both ways. Back in 2016, scientists described two new long-necked plant-eating dinosaurs from central Queensland, nicknamed Wade and Matilda. Big barrel-bodied animals, distant cousins of some of the largest creatures to ever walk the planet. What made them stand out wasn't just their size, it was who their closest relatives turned out to be. Their nearest cousins weren't in Asia or anywhere nearby. They were in South America. Which means the most likely way their ancestors got to Australia is that at some point, around 105 million years ago, they just walked there. Not across an ocean, across Antarctica itself, using it like a bridge between two continents that otherwise had zero business sharing dinosaur family trees. For most of the Cretaceous, Antarctica would have been way too cold, even without ice, for a slow, heat-hungry animal like this to make that trip. But researchers think there was a short warm spell, a temporary jump in global temperature, that opened the door just wide enough for a slow migration to sneak through before it slammed shut again. Which means somewhere out there, buried in Antarctic rock nobody can dig up because it's sitting under kilometers of solid ice, are almost certainly the fossilized remains of the exact dinosaurs that made that crossing possible. We just can't get to them. And it wasn't only the plant eaters making that trip. In February of 2025, researchers working that same Victorian coastline that gave us Koolasuchus and the polar dinosaurs announced something that flipped the whole predator side of this story upside down. Fossils pulled from the site included the oldest known megaraptorid remains found anywhere on Earth, plus the very first confirmed evidence of Carcharodontosaurs, a group of huge, shark-toothed predators ever found in Australia. For years, the assumption was that Australia's predator lineup would basically match South America's, where giant Carcharodontosaurs grew to sizes rivaling T. rex, towering over the smaller, faster megaraptorids underneath them. What this new fossil evidence showed was the exact opposite setup. Here, the megaraptorids were the big dogs, and the Carcharodontosaurs were the smaller, secondary players. Total reversal of the pecking order compared to the other side of that old land bridge. Same family tree, same Gondwanan roots, but a totally different outcome once you run it through 50 million years of isolation in a freezing polar forest. And this discovery didn't even come from some untouched wilderness expedition. It came out of an ongoing volunteer dig near a town called Inverloch, called Dinosaur Dreaming, a project that's been running for decades now and has pulled more than 10,000 fossil pieces out of that one stretch of coast, including dinosaurs, ancient mammals, birds, flying reptiles, marine reptiles, turtles, and fish. Which basically means the odds this Rift Valley still has more surprises buried in it are extremely high. Speaking of mammals, this polar forest was quietly rewriting mammal history too, just on a much smaller and stranger scale. Alongside all these reptiles and amphibians, researchers pulled tiny jawbones and bone fragments out of the same rock belonging to some of the earliest known relatives of Australia's most famous modern animals, including an ancient monotreme, part of the same family that gives us the platypus and the echidna today, animals that lay eggs but also make milk, and basically exist nowhere else on the planet. Even back then, In a rift valley shared with an ambush amphibian and dinosaurs with huge night vision eyes, the blueprint for Australia's uniquely bizarre wildlife was already quietly taking shape. So that's the world we're talking about. A slow-motion rift valley sagging apart bit by bit, home to small, warm-blooded dinosaurs with night vision, an ancient amphibian playing top predator basically by default, long-necked dinosaurs and their cousins sneaking across a temporary Antarctic bridge, and Australia's own weird mammal lineup already forming quietly in the background. All of it sitting less than 1,000 kilometers from the actual South Pole. Which brings us to how it all ended, because none of this lasted, and the way it fell apart tells you just as much about Australia as everything that came before it. The actual separation was almost unbelievably slow. Geologists figure that through most of the mid-Cretaceous into the Eocene, Australia was pulling away from Antarctica at a rate of roughly 10 meters every million years. That's not a typo. This wasn't some dramatic tectonic snap. This was a multi-hundred-million-year-long breakup happening slower than continental drift usually even bothers to move. For tens of millions of years, the gap between the two stayed narrow enough that a shallow sea crept in from the west and slowly widened, while the two land masses just kept sliding past each other instead of cleanly pulling apart. Then, somewhere around the boundary between the Eocene and Oligocene, roughly 34 million years ago, the gap finally opened deep enough and wide enough for full ocean water to punch through what's now called the Tasmanian Gateway. And that one event changed the climate of the entire planet. Once deep water could flow freely between Australia and Antarctica, it linked up with a similar new gap opening between South America and Antarctica on the other side of the globe, and together those two gaps let a continuous loop of ocean current form, completely circling Antarctica for the first time ever. That current is called the Antarctic Circumpolar Current. It's still there today, still going around and around the frozen continent non-stop, and its formation basically cut Antarctica off from the warm currents that had been keeping it mild its whole existence up to that point. Once that warm water stopped reaching the coast, Antarctica had nothing left protecting it from its own position at the bottom of the planet. Ice sheets started forming almost right away, and instead of stopping, they just kept growing, feeding off their own success. Because ice bounces sunlight back into space, instead of soaking it up, which cools things down more, which grows more ice, which bounces back even more sunlight. Within a few million years, what had been a warm, green forest full of giant amphibians and night-vision dinosaurs was buried under an ice sheet that has, with only minor wobbles, stuck around for more than 30 million years since. Australia, meanwhile, just kept going. Freed from Antarctica, it drifted north, out of the darkness, out of the cold, straight toward the equator, a trip it has genuinely never stopped making. Every single one of those small polar dinosaurs, the giant amphibian, the early monotremes, the early megaraptorids, all of it got left behind on a continent that then buried its own history under kilometers of ice, sealing away whatever else might have been living there, right when the lights, quite literally, went out for good. So next time you picture Australia, red dirt, blazing heat, kangaroos hopping through the shimmer, remember that none of that existed yet when this story started. This continent spent tens of millions of years as a cold, dark, forested rift valley, sharing a coastline with the actual South Pole, sharing its wildlife with Antarctica and South America, and sharing its top predator spot with an oversized amphibian nobody expected to still be alive by then. It only became the sunburnt country we know by drifting straight away from the one continent it used to refuse to let go of, leaving that other world behind to freeze solid, alone, under ice it still hasn't escaped from to this day. Thanks for watching, and if this is the kind of thing you're into, you know what to do.